In this installment, we're going to look at the relationship of angles formed by a transversal across two or more other lines. And to begin with, let's look at just how two lines intersect one another. So when we have two lines intersect, we've got basically just two different relationships here. There's the angles that are across from one another. Those are known as vertical angles, and they are congruent to each other. And that makes sense because as if you picture a pair of scissors, as they open and close, the opposite angles are going to increase or decrease at the same time. The other relationship is the two adjacent angles. Together they form a straight line. So that's a pair of angles forming a line. That's a linear pair. And all of the other relationships are formed by the transversal crossing the other two lines. And for those, let's look at that at an angle. So we've rotated our figure 90 degrees. The foundational relationship here is corresponding angles. Got that one here at the top with the other two definitions that are corresponding angles, that would be formed if you were to sketch these and just cut the line and shift one intersection to overlap the other. And so here, this angle 3 and this angle 7 are considered corresponding angles because when you slide them up, they correspond. They overlap one over the other. So that is the corresponding angles relationship. All of the other, as they're proved, are based on corresponding angles, and they're either interior or exterior, and they're alternate or consecutive. Interior refers to in between the two lines. So angle 2 and 4, angle 5 and 7 would be interior angles. Angles 1 and 3, 6 and 8 are exterior angles. And then if they are alternate, that means one side to the other. So if one's on the left, the other's on the right, that would be alternate, and consecutive is down the same side. So 3, 4, 7, and 8 are all on the same side. So the relationship between, let's say, angle 4 and angle 5, they are on alternate sides. They're on opposite sides, and they are in between the two lines, so that would be alternate interior. 2 and 7 are also alternate interior, and 3 and 6 alternate exterior, because they alternate one side to the other, and they are on the outside, the exterior of the two intersected lines. And consecutive interior, 4 and 7 are consecutive. 3 and 8 would be consecutive exterior. All of the alternate angles are congruent to one another. All of the consecutive or same side angles are supplementary to each other. That is, if these lines are parallel. And there's only one set of angles that doesn't have a special designation, and that would be, an example of that would be angle 3 and angle 5, because it's like a linear pair of the consecutive angle. It doesn't have a special name. Other than that, they have all got interior, exterior, alternate, and consecutive, and the three that are all the foundational relationships: vertical angles, they're congruent. A linear pair are supplementary, and corresponding angles are the same, so they're congruent. The relationships, the special designation between the two angles is not dependent on the two lines being parallel. In fact, If we just looked at these, ignoring that intersection, we've got a transversal cuts across two. Even though these two lines do cross each other down farther, we would still can compare alternate interior, alternate exterior, and etc. with those angles. And same with these down here. Any two lines that are crossed by a transversal has those designations. So try your hand at a few of these. What is the relationship between angle 1 and angle 12? Well, this is the transversal. 1 and 12 are on opposite sides, so they're alternating, and these are exterior angles. How about angles 1 and 6? Here's 1, 6. Line M is the transversal. 1 and 6 are both on the same side, and they are not between, so they're exterior, so those are consecutive exterior or same side exterior. How about angles 6 and 14? 6 and 14. Well, they use T as a transversal. They're on the same side, and since they're both above, one's inside and one's outside, but they're both above their lines, so those, if they were shifted, one was shifted up or down, they would overlap, so they are corresponding angles. How about 9 and 7? Well, what transversal do 9 and 7 have in common? Well, if we ignore the other intersections, angle 9 and angle 7, they don't have any transversal that they share. There's no line that is shared between them, so they have no relation. They're on completely different intersections. So no relation between those. How about 13 and 15? 13 and 15, they're formed by that one intersection. So if we ignore all the other lines that are not used in forming those, if there's just two lines form the angles, then they're either a linear pair or vertical. And 13 and 15 are a linear pair because they form the straight line there. So randomly pick any two numbers between 1 and 16 and see if you can determine what the relationship is between those angles and whether or not they would be whether or not they'd be congruent or supplementary, or if they may, well, some of them have no relation, but if the lines are parallel, then they'll either be supplementary or congruent.